Okay, good morning. Good morning, all of you. Welcome to Unacademy YouTube class. Welcome to Unacademy YouTube class. Today, I am going to explain electrode potentials. Electrode potentials chapter. Myself, KNR, top educator in Unacademy for TS and APMCET. So please subscribe YouTube Unacademy channel by using my code KNR Live. Okay, today I will explain electrode potentials topic. So what are electrode potentials? What are electrode potentials? What are electrode potentials? The charge difference developed in the charge difference developed in the interface of electrode potential when a metal is placed in contact with its ions solution. Some charge difference is observed at the interface of the metal and its ions solution, or when a non-metal is placed in contact with its ions solution at the interface of metal and its ions solution. Some charge difference is developed. So above the solution anta oka charge untadi, below the solution anta another charge untadi, and we observe a clear charge difference at this point. This charge difference developed at the charge difference developed at the interface of a metal and its ions solution, or a non-metal and its ions solution is called electrode potential. Denoted by capital P. So what is electrode potential? The charge difference developed at the interface of a metal and its ions solution, or a non-metal and its ions solution is called electrode potential. What is the significance of this electrode potential? It represents the tendency of an element, the tendency of an element, the tendency of an element to undergo oxidation, tendency of an element to undergo oxidation or reduction, tendency of an element to undergo oxidation or a reduction, tendency of an element to undergo oxidation is called oxidation potential. Denoted by E oxidation. Tendency of an element to undergo oxidation is called oxidation potential. Tendency of an element to undergo reduction is called reduction potential. Tendency of an element to undergo oxidation is called oxidation potential, and a tendency of an element to undergo reduction is called reduction potential. For any element, oxidation potential is equal to reduction potential, but opposite in sign. For any element, oxidation potential is equal to reduction potential, but opposite in sign. Okay, and this electrode potential mainly depends upon electrode potential mainly depends upon nature of the element. Nature of the element. Second one, concentration of electrolyte solution. Concentration of electrolyte solution. Third one, temperature. These are the main factors which affect electrode potential of an element, and electrode potential at 25 degrees centigrade, 1 atmosphere pressure, and in its 1 molar ions solution, in its 1 molar ions solution is called standard electrode potential. Standard electrode potential. denoted by E naught. So under normal conditions, charge difference is called as electrode potential under characteristic temperature, characteristic pressure, and characteristic concentration. Electrode potential is called as electrode potential, standard electrode potential. It only depends upon standard electrode potential. E naught only depends upon nature of the element. Only depends upon nature of the element. It is independent of concentration of the electrolyte, temperature. Only depends upon nature of the element. Okay, now E naught value depends upon three factors. Even, but E naught value only depends upon one factor. That is the nature of the element. Nature of the element. And the systematic arrangement of various elements in the increasing order of the standard electrode potential is called as electrochemical series. Electrochemical series. What is electrochemical series? The systematic arrangement of various elements. Systematic arrangement of various elements in the increasing order of their standard electrode potentials is called electrochemical series. Electrochemical series. Element having lowest electrode potential is lithium. Next one, potassium. Next one, calcium. Next set, sodium, magnesium, aluminum. Next one, zinc, iron, hydrogen. Next one, copper, silver, gold, and fluorine. Between silver and gold, bromine and chlorine. Between copper and silver, mercury and iodine. ఇవి మనకి frequent గా యూస్ చేసే ఎలిమెంట్స్ in the increasing order of their SRP values. Okay, na? Element having a lowest SRP, lithium, highest SRP, fluorine, and SRP of hydrogen is considered as 0. So from top to bottom SRP value gradually increases. So elements which lie above the hydrogen exhibit negative SRP values, which lie below the hydrogen exhibit positive SRP values, negative SRP values, positive SRP values. Okay, na? So above the hydrogen, most of the elements are metals. Below the hydrogen, most of the elements are non-metals. Generally, metals act as electropositive elements. Non-metals act as electronegative elements. Metals act as reducing agents. Non-metals act as oxidizing agents. So, with the help of electrochemical series, we can predict the nature of an element, whether it is a metal or non-metal, whether it is a reactive or less reactive, and what is its nature. It acts as oxidizing agent or reducing agent. Extra can be predicted by SRP values, electrochemical series. Okay, so as SRP value increases from top to bottom or from lithium to fluorine, as SRP value increases, as SRP value increases. First one, as SRP value increases, metallic nature from top to bottom, metallic nature decreases, and non-metallic nature increases. As SRP value increases, metallic nature decreases, non-metallic nature increases. And B, as the metallic nature decreases, electropositive character decreases. Electropositive character decreases. As a non-metallic nature increases, electronegative character increases. Electronegative character increases. And C, as electropositive character decreases, reactivity of metal decreases. As electronegative character increases, reactivity of non-metal. Reactivity of non-metal increases. Reactivity of non-metal increases. ఇవి frequent గా ఇచ్చే మోడల్స్ థియరీ బేస్డ్ క్వశ్చన్స్ on electrode potentials. As SRP values increases, metallic nature decreases, non-metallic nature increases. Electropositive character decreases, electronegative character increases. Reactivity of metal decreases, and the reactivity of non-metal increases. Okay, and one minute. And as SRP value increases, student, lithium to fluorine electropositive character decreases. Electronegative character increases. Okay, na? So, as SRP value increases, another important feature. Electropositive character decreases from top to bottom. Reactivity decreases. And metals which lie above the hydrogen exhibit high reactivity. Below the hydrogen exhibit low reactivity. Generally, high electropositive elements displace low electropositive elements from their compounds. Therefore, metals with low SRP. Metals with low SRP means they lie above the series. They lie above the series. Metals with a low SRP will displace. In case of metals, displacement means reduction. They will reduce. Okay, now metals with low SRP will displace. Metals with high SRP. Metals with a high SRP means they lie below the series. So metals with a high SRP, low SRP will displace metals with a high SRP from their compounds. Or from their aqueous salt solutions. Above the series can displace below the solution. Above the series can displace below the series. Okay. For example, magnesium above the series when it reacts with zinc sulfate solution. Due to its high electropositive character, magnesium can displace zinc from its salt solution. Similarly, zinc, when it reacts with copper sulfate solution, zinc above the series, so it can displace copper from its solution and forms copper. Copper below the series, when it reacts with magnesium sulfate aqueous solution, no reaction will take place because magnesium above the series, it can displace copper from copper sulfate solution. It cannot displace magnesium from its salt solution. Okay. And another important feature is non-metals reactivity. From top to bottom, reactivity of non-metals increases. So non-metals with high SR, more reactive will displace, less reactive. Therefore, non-metals with a high SR. High SRP means they lie below the series. So non-metals with a high SRP will displace. In case of non-metals, displacement means oxidation. Non-metals with high SRP will displace. Non-metals with low SR. Low SRP non-metals like above the series. Okay, and in case of non-metals, below the series can displace above the series. The metals exactగా reverse. In case of non-metals, displacement is called oxidation. For example, chlorine when reacts with potassium iodide, chlorine below the series, iodine above the series. So it can displace iodine from its salt solution. But iodine cannot displace chlorine from its salt solution because it is a lesser reactive than fluorine. That's why no reaction will take place. Okay. And another important feature from electrochemical series is elements which lie above the hydrogen. So hydrogen పైన ఏవైతే ఉంటాయో elements which lie above the hydrogen can liberate hydrogen gas from water or from dilute acids. Okay, from water or from dilute acids. So elements which lie above the hydrogen అంటే చాలా ఉంటాయి. So వాటన్నింటిని ఐడెంటిఫై చేయడం very difficult. That's why below the hydrogen గుర్తుపెట్టుకోండి. Below the hydrogen copper, silver, gold and mercury ఉంటాయి. They cannot liberate hydrogen gas from water or from dilute acids. కాబట్టి ఈ 4 ఎలిమెంట్స్ గుర్తుపెట్టుకుంటే చాలుగా. ఓకేనా? So the about electrode chemical series and last feature of electrochemical series is as the distance between electrodes increases, as the distance between electrodes increases in electrochemical series. As the distance between electrodes increases, EMF of the cell increases. These are the characteristic features of electrochemical series. And for any cell, EMF is equal to EMF of the cell is equal to E naught of cathode minus E naught of anode. ఇప్పుడు if we consider SRP1, if we consider oxidation potential values, SOP values, EMF of the cell is equal to E naught of anode minus E naught of cathode. The formula to calculate EMF of a galvanic cell. Okay. So in next class I will explain numericals based on Nernst equation and the significance of Nernst equation. Okay. Thank you. Bye.